Hello, welcome folks to this introduction to SQL. My name is Lucas Varela. Can you hear me? Hi Alex, thank you. So welcome folks, welcome to this introduction to SQL. We will start in just a moment. I'm going to start by sharing my presentation so we can start talking. Um, so on SQL. So, hi Alejandra, hi Estelle. So welcome again to this introduction to SQL. Today we're going to have a very interesting topic and a topic that is important across many disciplines. Is basically SQL is the cornerstone of data. Basically, you have data analysts, data scientists, data engineers, everybody uses SQL. So the idea is that today we're going to take a moment to discuss this very interesting subject and see a couple of, an applied case that is going to help us introduce the basic commands of SQL and see how SQL enters into action to help us, get data and answer some questions. Before we start, let me just take a moment to introduce DataScientest. At DataScientest, we are dedicated to teaching basically everything that has to do with data, and also we are currently expanding to some interesting directions like cybersecurity and DevOps. I will talk about this in just a second. But here at DataScientest, we are more than 120 data experts that are dedicated to creating and teaching content on data, on cybersecurity, on full stack knowledge. And We here at DataScientest have a lot of experience already on this. We have more than 10,000 users, more than 3,000 students that were deployed in the last 12 months. So let's say we know what we're doing, and also we have a very interesting catalog of programs to offer you, so you can have training such as the data analyst training, the data scientist, data engineer, ML engineering, so ML ops engineering. We have also programs in data management, in data product management, in marketing. We have basically a program for every taste. We also have what we call the Cyber University, which specializes more on IT and security, and the Dev University, which specializes on IT development alone. So that is DataScientist. But also we make part of the OBNES group. It's a huge French education group that has more than 200K alumni, 15 schools, 40K students. So really our infrastructure, we make part of a huge organization that is going to, let's say, verify that the content is of top quality. We are also proud to have partners, to have part of our team that has that are certified AWS AWS certified trainers. We have partnerships with top universities such as Mines de Paris. Uh, we are Qualiopi certified, which is basically the certification given by the French government to basically to assure that there's the quality required for an institution. We have companies from the 30 most important from the 40 most important companies in France that trust us with their trainings. So yeah, that's just to tell you a little bit about us and to encourage you to take one of our courses if you're interested in learning data science, data analysis, and one of the topics we can share with you. So that's data scientist for you. Now let's get into the topic, into what you came here for. Let's start by introducing a scenario. So imagine you, let's say, are hired or you belong to a insurance company, and this insurance company wants you to use their data to analyze patterns in their clients' accidents. So they have insured some clients, and and basically what you want to know is there something I can use from the previous accidents to learn about them and to improve our service? So in this particular scenario, we're going to focus in two simple questions. Of course, we have to start with something simple so we can use it for an introduction. And the idea is that in this scenario, and this is what we're going to do at the end, we're going to identify clients that are risky for us. In particular, we're going to analyze the age, the age, how age impacts in the accident. So how many accidents does a particular age group has, for example. And also, we're going to try to detect, or we're going to see if there's seasonal trends. So, are there more accidents in January, in February, or is it always the same? So, do we have the same amount of accidents all year round? Those are the two questions we want to answer. And now, what I want to ask you is, to answer these questions, what do we need? So let me just go back. What do you think? Let's say are the in the big steps that we need to do to solve this question. What is the first thing we need in order to answer a data question? We need data, right? So a big part of this masterclass this webinar is going to be dedicated to answering how data is obtained, how data is stored, and then once we have that data stored, well, the next part that comes into our analysis is, or into our process, is analyzing it. So to analyze it, we have to go and search this data again. We have to search the relevant data, and then we can start doing some analysis. Okay. So let's start by talking about the cycle of data, right? So uh, when we say, okay, we're going to use data, well, data doesn't come from a magical place. Data comes from different sources that we're going to need to extract. Basically, we're going to search for data in our company. For example, if we're in an insurance company, we're going to search in our databases or in our different teams the data of our clients. So maybe for example, the team of sales has collected data like the age, the vehicle age, the address, the license details, things like this are going to be gathered by our agents. But then, as data analysts or data scientists, or basically anybody who wants to solve the questions that we want to answer today, we need to extract this data. So we're going to go and search for the data. And this data is going to come in various different formats and from different sources. So as I said, this data could be maybe stored in a CSV file or an Excel file by our sales team. Then maybe we're going to want to get more data on the accidents themselves. So maybe what were the conditions of the accident? Was it, uh, after hours, late at night? Was it in the morning? Was it a severe accident? Were there other people involved? This kind of information could be useful, so we can also go and search this. For example, in France, this data is made publicly available, so we could go and ask for the French to the French government database, please give me this information because I need it. And all of this data from different sources. So as I said, there are some sources that are external, some that are internal. We're going to go and grab all the things that we need. And then we're going to process this data. So here we're going to transform this data and we're going to load it to a place where we're going to store it. We're going to call this place a data warehouse. So here I have to say that there's different things or different ways you can manage data. Today I'm going to introduce one way, which is the one I'm describing, in which you grab data, you transform this data. So for example, you put everything in the same format. For example, maybe you have a sales team from from different regions. So maybe some sell in Paris, some sell in the south of France, in the north of France, and each one has their own way of storing data. So we're going to put them all in the same in a similar format so we can use them together. And then we're going to load it to a place we're going to call a data warehouse. But what exactly is a data warehouse? So the idea is that in data, we're going to distinguish two very different scenarios. We're going to distinguish data that is going to be used in a transactional scenario, which we're going to call the OLTP. And we're going to have data that is going to be used for analytical purposes, which is going to belong to the OLAP scenario. But what exactly does this mean? So let me give you an example of a transactional scenario. So data helps us store information and use this information to provide services to our clients. For example, if you have a bank, one service that you want to offer your clients is the possibility to make a bank transfer. In this case, we're going to be we're going to have what it's called a transactional scenario, because the processes that involve this database are very particular. They need to be fast. They need to be they need to be efficient. You're going to store a lot of data, and they need to be reliable, because let's say the data that you're going to store here is um, important, right? When you're making a bank transfer, you want to be careful not to delete information from your clients, because it's basically their money you're handling. So in this case, for example, the service that you offer is, okay, a client wants to make a bank transfer, then your database is going to take this request. It's going to look in the database where data is stored. If let's say the two accounts exist, then it's going to perform some checks. For example, is the account that is sending the money, does it have enough money to perform the transaction? If so, then it's going to proceed to update the balance of the two accounts. So it's going to subtract the money or the amount from the account that is sending it, and then it's going to add it to the account that is receiving it. And finally, after all this is done, the database is going to return an answer, basically saying the transaction was successful, or the transaction didn't happen because there's not enough money, or one of the accounts doesn't exist. And then the client is going to know the result of this transaction. So just to reiterate, this type of process needs to be fast. You don't want clients waiting for days to see if a transfer took place. It's going to happen at high amounts of volumes. That people make transactions often, so it's a process that is happening a lot of times, very quickly, in a short term, in a short period of time. And again, this kind of procedure is very you need to be very careful not to let's say make a mistake, because it's crucial information. It's the data that you're handling is possibly the life savings of someone. So this type of scenario is called an OLTP. So data is going to be stored in a particular way, so that the database is capable to satisfy the requirements we just said. So basically here you have a summary of what I just said. Transactions need to be quick, resilient, they need to be updated, the database need to be updated frequently. Now, that is the first scenario. But now let's talk about the second scenario that interests us, the OLAP. So this is the analytical scenario. In this case, you're going to solve a question using data. Here, for example, we have the case where a manager has asked a data analyst or a data scientist to answer the question, which of the stores are selling the most this month? So you can imagine we have a clothing store, a clothing brand, and we want to see which of our stores is doing better. So what is going to happen here is you're going to go and gather the information for all the transactions in the last month. Then you're going to perform complex operations, or at least more complex than in the previous scenario, like adding all the rows by the same that have the same store, so that you can get the average or the total sales per store. Then you're going to store this data in a new database, and then you're going to connect this database to a reporting system. So you can think of this as something that takes the data and then creates visuals and metrics and basically it creates something, a dashboard, something that has the visuals and the metrics that you need to analyze the performance of your stores. Finally, you're going to send this dashboard to your to the manager and to the persons that to the people that are involved in the monitoring of the sales for that store, and then they're going to take decisions based on this. For example, maybe you notice there's a store that is selling a lot less than the others, so you want to, send somebody to check, to do an audit to see what is going on. Or on the contrary, maybe you have a store that is doing so well that you want to send somebody to, well, ask them what they're doing so that you can replicate this in the rest of your stores. So this scenario, called the analytical scenario, is not going to be at all similar to the previous case, because here you're answering a question that, well, is not, you don't need to give the answer in 1 minute or 2 minutes. This is more a project that you're going to develop in weeks or maybe months. It is not involving crucial data. So you're not manipulating the data of your clients. You're creating a copy and then you're working with that copy. So if you make a mistake, so if you delete this database, the OLAP, it's not as critical as manipulating an OLTP. So we have two different needs, and for each need, we have a different type of database, okay? So now you might be asking, why am I talking about the two different types of databases that you're going to encounter? Well, the idea is that for our purpose, what we're going to use is only the OLAP scenario, so the analytical scenario. We want to have a database that has, you know, uh, aggregated data of our clients. For example, the sale, the accidents per group page or something like this. But we can, let's say, we need to know about the OLTP, the transactional scenario, because transactional databases are going to be the basis for analytical databases. So even if for our precise purpose or for our end goal, we don't need to use the transactional databases, at some point we need to, let's say at the beginning, we need to search the data, and most likely we're going to go grab data from the transactional scenario, transform it, and get our analytical database. So here we have an example of how an operational database looks like compared to an analytical database. So in an operational database, we have the information for every row. So here, for example, we have a transaction for store one that involved the sale of a product called product one, and the amount. So we sold 132 items, and this sale was approved. So we have data that is not aggregated, that is very, let's say, molecular, in the sense that you have, let's say, the information for every transaction. So this type of database is going to be updated frequently. So every time we make a sale, we're going to add a row here that is going to help us keep track of all the sales that we want. So we need to quickly be able to modify it and retrieve it, so we can get the information regarding a particular sale. This database is going to be hard to analyze. So you can see here that it's hard to get insights from this table, right? Like if you want to answer, for example, which store sold the most or which product is the most popular, well, you're going to need to count basically here and do mental math to get the result. And here we're talking about a small table, but if it's a real table for a let's say for a real scenario, this table is going to be huge and it's going to become very hard to analyze. On the contrary, we have the analytical database, which doesn't have the information for every transaction, but rather the aggregated or the, let's say, when you add for example, the total sales. So here, instead of having each sale, we are going to uh, sum all of the sales for product one. So you see that there's in total. So this would be the adding um, this and this. This would add up to 210. Then we do the same for store two. I think I confused them. So actually, we have to add the amounts for store one. So this, and this will give 210. Then if we add the values for two, so for store two, so this and this, we get 99. And then if we add all the values for store three, we get 90. So the total sales per store. And then we go and see, okay, which is the product that is sold the most? So here we can see that for store one, it's always product one. So one. For store two, well, here it's product two. And then for stores three, it's again product two. So we can answer questions, analytical questions from this database very easily. So just to summarize, we, as data analysts or data scientists, basically we are mostly involved in the analytical scenario, whereas data engineers, which basically are going to be the ones managing the architecture of the databases, are going to handle both. So they will mostly be involved with the transactional databases, but they can also be involved creating analytical databases. So just to recall, we care about transactional databases because they're going to be the basis many times to construct our analytical databases. Here we have another example of how a more involved operational database looks like. So we're going to have a central table here that records all of the transactions. And then if we want more information on a particular dimension of the transaction, for example, I don't know, the city, we can go to this table that is going to have all the data of the cities, and then we have another table that has all the information about the products. This way of storing data basically ensures that the data is not going to be redundant, so that you're not going to have data that is repeated. So in the end, you get a database that is really fast and quick to update. Then, well, from this operational database, we can obtain several examples of analytical tables or databases here that basically have answered to particular questions. So here we want to answer questions at the level of a store. So we grab this table, and we compute the total sales per country, per city, sorry. And we see, for example, that Paris is the store that sold the most. Here, we want to answer questions. We want to know about the which product sells the most, and we see that pens are the leading item in sales. Then here we want to answer a question on a level of a country, and again we use stores and transactions, the two tables from our operational database, to construct this new analytical database. So from this we can create this. Now let's talk about the relational model. So if I go back, you can see that these tables produced, for example, let's take the first analytical database. This table is constructed from the stores table and the transactions table. But how did we put these two tables together? The idea is that we grabbed the first column here, which is called the transaction ID column, and this is what we're going to call a primary key. So a primary key is going to be a value that uniquely identifies, or a column that uniquely identifies every row in your table, okay? If we go to stores, then we're going to have another primary column, which is store ID. So here, each store is uniquely identified by the store ID. And how we put these two together is basically by adding a column here that is going to be called a foreign key, that is going to be the primary key of another table. So you see that store ID here is a primary key, but here it's a foreign key. So it's not unique. You can see that store ID is repeated in this table, but it helps us connect these two tables. So if I want to know the information of this transaction for, or the store for this transaction, I go search store ID in the store table, and I know that this transaction was made in Paris. This transaction was made in Paris. This transaction was made in Los Angeles. This as well. And then, for example, the last one was made in New York. So this is what is known as the relational model. The idea is that you're going to construct tables that are uniquely identified by their primary key. So you see each table has their own primary key. And then you're going to communicate them through a foreign key, which is just the primary key of another table inserted to a table, to another table. The relational model is, well, here I just want to introduce, let's say, how we relate tables, but it goes further into ensuring that basically by building our tables like this, we will ensure that our data is easy to find, that it's valid, so you're not going to introduce errors in the database when you follow the relational model. And also, it's a way to ensure that as many people as possible are able to use the database simultaneously. So all of these things are, let's say, guaranteed by the relational model, but we will not go deeper into this topic. This is just to motivate why, let's say, the OLTP exists, and why basically why data is stored like this and not simply as a huge table that has all the information in the same table. That's basically the explanation to why this happens, why we store data in this, uh, separated fashion. Okay. I see. Yeah, somebody, Stefan said it's a join. Yes, the two tables. What we're going to see later on is that in SQL, the basically what this translates to is to using a join. That is exactly correct. Okay, so now how do we construct analytical databases? What we're going to do is a process called an ETL, which is basically we go to the different data sources that we have, we transform our data so that it is in the way we want, and then we load it to the place where it's going to be stored. So the data warehouse. In the data warehouse, we're going to have our analytical databases, and then we're going to be able to use them. So to summarize, and this is where the theory ends, and we will start our applied exercise. We have data that comes from production and from external sources, as I said in the beginning. This data is going to be collected using an ETL, so a process that goes, fetches the data, transforms it in a way, and then it loads it in a data warehouse. And then from the data warehouse, we're going to be able to extract the information, which is already processed to a certain degree, to create our own analysis. So if you're a data scientist, you're going to train a model using this data. If you're a data analyst or a BA analyst, you're going to create BI reports, so visuals and metrics that are going to allow to monitor the performance of your operations. And that for you is a introduction to, let's say, data warehousing. So let me just come back to the scenario. So the idea is that in our scenario, the first thing that needs to be done is somebody, the data engineer or a data analyst, is going to go and search for all the data that is needed, and they're going to store it in a data warehouse. And then us, in this scenario, we're going to go access that data in the data warehouse, and we want to ask the data warehouse questions about this data. And that is exactly what we're going to do using SQL. So now we are going to start discussing SQL. So the idea is that we need to get deeper into the use case that we're going to solve. The idea is that we're going to have two data frames. So we're going to have a data frame that has information about the global accidents in France, and then we're going to have a database that has information on the clients of our company. Okay. So we're going to go and look at these two tables, and we want to answer two questions. We're going to first start by answering which age groups are the most expensive, let's say. So which ages, for example, are 21-year-olds the ones that are creating the most expensive accidents on average, or is it people in their 50s? This is what we want to know. Okay, so for this we're going to go to Snowflake. So in Snowflake, basically you have it's a computing and data warehousing service where you can store data online or process data online. So this is how this looks like. So the idea is that right now I'm in a web browser, and in that web browser, I'm going to go to snowflake.com. I'm going to log in to my account, and there I'm going to be able to access the data that I have stored. So for example, here, if I go to the tab that is called data, you see that I have several different warehouses. I have one, for example, that is called accidents. And if I go to accidents, you see that I have several tables. So for example, here I have customer base. And here I can see, well, how the table is constructed. This, we will not discuss it today. But we can see, for example, the columns that we have and a preview of the data. So for example, in customer base, we have a column that is called client ID, another one that is a identifier of the accident, the state of residence. So this number uniquely identifies a region of France. Then we have a column that says if the client has a premium subscription or not. Then we have the cost of the accident. We have the license year. We have the vehicle age, the genre, the gender, sorry, and the client age. Okay, so this is the table that has the information on our clients. And for the first part, we're going to only focus on that. So the idea is that I can click here on projects, and I can create a SQL worksheet. And this is going to open a space where I'm going to be able to basically run SQL statements, right? SQL queries. The first thing I want to do is connect to my data warehouse. And now I'm going to be able to code SQL code, right? So the first thing I want to show you is one of the first things you learn in SQL is how to see the whole table. So the idea is that let me just take a moment to explain. SQL is a language that is going to allow us to go ask a question to, for example, the table. And then I want to, for example, see all the table. So the first thing we're going to do is I want to see the whole table displayed. So what I'm going to do is I'm going to write select. I'm going to use this little asterisk. And then I'm going to write from and then the name of the table. So the table is called customer base. So what this is saying is basically almost plain English in the sense that it says select this star, which means all of the columns from customer base. So if I execute this, I get this result. So here you see that I have a table with all the parts of my table that match what I asked for. Okay, so I I said go fetch the whole table, and then I get the whole table. Okay, now the first thing I want to ask to you is so here you see that I have basically capital letters and lowercase, upper and lowercase. Do you think it's necessary to use upper and lowercase? Uh, I see here there's a question. So, is Snowflake free? No, but it has a free trial. And if you want to test SQL, you don't need to use necessarily Snowflake. There's many alternatives. For example, um, you can use SQL in Python using SQLite, and there's online websites that let you practice SQL. So it's not the only place where you can see where you can use SQL. So just to answer the previous question I left, actually, it's not necessary to have uppercase. I could have written, for example, this. So select everything from customer base, and you can see it works just fine. I could also write everything in the same line. For example, here, if I write this, the code is going to work. So let's say SQL is cap insensitive, so case insensitive, and line break insensitive. So you can write everything in a single line if you want, but it's a bad practice. So what let's say is expected from you as a somebody who codes or writes in SQL language is to basically separate or to make line breaks at every part of your statement so it's easier to read. Okay. Now, the next thing I want to show you is, okay, here we brought all of our table, but for now, let's try to limit the number of rows that are shown, because every time I run this, I'm doing a very resource intensive query, because I'm bringing the whole table, which is more than 10K rows. So for our example, I'm going to limit our result to the first 10 rows. So how do I do this? I add a new statement at the very end, which is called limit, and then I specify the number of rows that I have. So before I run this, take a look. I have, 10,000 rows. And after I do this, so I'm going to run this again. You see that now I only get 10 rows. I'm going to close this so we can see the whole table more easily. Okay, so far so good. We have our table. But now that we know our table, that we know the data that we have, we want to basically answer questions about the age of our clients. So what we would like to do is to grab all the clients that have the same age. So for example, here I would let's say my table only has these 10 rows. I want to grab this row that has a 42-year-old and this row that has also a 42-year-old, and I want to average the cost. I want to see on average what is the cost for accidents of people with 42 years. I want to do the same thing for each age group. So what I'm going to do is I want to, let's say, average this by age. So how do I do this? The idea is that here, the first thing I want to do is I'm going to get rid um, of the of the columns I'm not going to use. So the first thing I want to do is, okay, I'm going to keep only the client age. So instead of using an asterisk, I'm going to replace this by the names of the columns I want. So for example, client age, comma, so I can continue with a with a with the next column, and then I'm going to use cost. Okay. So by doing this, when I run the query, you're going to see that now I only get two rows, the client age and the cost. Okay. So now that I have only the rows that matter to me, I would like to add every every value to average every value here that has the same age. So there's a function for this which is called group by that is going to do exactly that. So the idea is that if I add a statement that is called group by, and then I specify, for example, I want to group by client age. So I want to basically grab all the people with the same age. And then what am I going to do? I'm going to perform an operation on the cost. So the column cost is now going to give me the average cost. So here, if I perform this operation, you see that now I get, for example, the average cost of accidents for 32 year for people with 32 years. So on average, their accidents cost 950 euros. People with 25 years are more expensive. We usually pay, or on average pay, 1,000 euros. People with 43 years are paying on average 500. So you see there's a huge difference on what we pay for clients that are younger compared to some that are older. Okay, so well, we can already see that we have something interesting here. I cannot see all the ages because basically I'm limiting the result to the first 10 rows. But if I remove this, I get all the ages. So here I can search for any age and see what's the value they're paying. For example, here we see that 90-year-olds on average cost 460 euros, 65-year-olds 461, 24-year-old cost almost 1,000. So we start to see a trend. Okay. Now I'm checking here the comments. So there's a comment saying that SQL is not case sensitive. So let me show it. But uppercase is used for readability. So this is true, and this used to be the, let's say, the paradigm some time ago. But more and more, this is not, let's say, enforced. Notably because there's color coding that helps, let's say, give this readability. But if you want to be super strict, I do recommend you follow the advice of Shahir. I hope I pronounced that well. So then we have another comment here. Thanks for your comments. We can use order by for better readability. So this is exactly what we're going to do next. So if we check the results here, they're super hard to read because they're not in a order, in any order, right? We could order them by age or by cost, but in this way they're super the data is not easy to read. So this is what we're going to do next. But before this, I want to rename this column because I don't really like the way this is displayed. I want to use a name that is more that is basically plain English. So there's a way to do this, which is basically using aliases. So we can use as, and then we write the name we want. For example, average or mean cost per age. And then when I run this again, you see that the name is no longer average parenthesis cost, but basically the name we just defined. Okay. Now that we have renamed the column, we can proceed to order the result. So we can use order by. So this is going to basically allow us to order our results by any column. For example, we can choose by mean cost because we're interested in, well, knowing which are the accidents that are most expensive to the insurance company. So when I use order by, you can see that we get the ages, the cheapest ages, let's say, the ones that are not costing us, that are costing us the least. And towards the end, we have the ones that are the most expensive. So we can definitely see there's a trend here, right? Like people that have less, that are younger, seem to be involved in more expensive accidents. But this was not very practical. We had to scroll down to the very end. Fortunately, there's a way to invert the order here, which is basically by using the by adding these four letters, DESC, which is short for descending. So what this is going to do is modify the order in which the table, the ordering is done. So we sort the values from greatest to least. So here, when I run this again, you can see that now we have the most expensive ages, the ones that cost us the most, on the top. Okay. And now it is easier to get the result, to extract the information we want. I see here Stefan suggesting we use an alias, and yes, that's exactly what we needed to do. Thank you for your comments. Okay, so that basically solves the first question we wanted to solve. We wanted to see if there's a trend among our younger or by age groups, and we definitely see that there's well, some ages that are impacting more our business. Now, there's one last thing that I would like to do before we move to our next question. The idea is that here we are comparing. We have clients that are basically that have premium subscriptions and not. Let me just show you what this means. So I'm going to grab all the database again. You see that there's some clients that have a premium subscription and then others that have these ones don't have a premium subscription. The ones that have zero is meant to be it's a way of saying false, and one is a way of saying true. So here we did an analysis over all our clients, but we have to be careful because maybe there's some subtleties in the behavior depending on the type of client we have. So I'm going to copy back the code that we had before, and I want to add something to basically filter and only leave the result for my premium clients. Let's start by analyzing the premium clients. So does anybody have an idea of what could be used here to get a result only for our premium clients? Yes, so here we have a very good comment saying we need to use a where statement. So yeah, I see the public knows some SQL. So we're going to add a where statement, and it's important here to note that I'm not adding the where statement just anywhere. For example, I could use where here, for example, where premium subscription equals to 1. But if I do this, you see that there's an error, right? So we cannot choose a random place or a random order for our queries. There's some order to be respected. So here we need to start with the select, then we use the from, then the where, then comes the group by, and then the order by. So here now, well, it's hard to notice, but here we have filtered by premium subscription, and we see that still we have a behavior where the younger people are the most expensive. Maybe the only difference is that we see that the people with 32 years old, well, before they were a bit lower, but now they became more expensive. So our clients, our premium clients, are more expensive also when they have 31 years old. And now let's do this for our non-premium clients. There we see that literally we have all the ages below 27 basically that are causing us the most expensive payments. Okay, folks. So here we have an interesting remark. So we have to select the premium column also, otherwise it will not work. So this is not true actually. So let's show this in an example. For example, let's take again our whole data frame. So here, if we grab customer base, oops, and I'm going to limit it to 10. So here, let's say I'm going to keep only a couple of lines. So I'm going to keep number accident, which is going to help us identify each line, and premium subscription. So here, if I use where premium subscription equals to 1, you can see that, well, all of our results have premium subscription equals to 1. But if I remove this, notice that the result is not going to change. We're still filtering by premium subscription. So there, if I run this again, I have the same numbers. So it's a bit hard to keep, but let's, oops, I did something weird here. So yeah, you have the 44, 67, 92 as the first columns, and then if I remove this, it's the same thing. 44, 67, 92. So it's a very good remark, because it's a bit counter, or it's very counterintuitive, because even if we excuse me, even if we don't keep a column that so if even if we don't select a column that we're using after, it's still we can still use it. What we're saying here is, at the very end, we want to keep only those columns. Okay. Okay, so now let's move on to the next question we want to solve. So the idea is that now we want to solve a question regarding basically the season, right? So we want to see which are the months that have the most accidents. So if I show you again the whole table, you can see that in this table there's nothing that tells us the month for the accident, right? So we cannot use this table for our purpose. But fortunately, if I check the other table that we have, so there's another table here which is called features. Here I have the month of the accident with several other pieces of information. So let me just show you how this looks like. So we have here basically information on the place it took place, the accident took place. So like the address, the GPS coordinates, the city, the severity of the accident, the atmospherical conditions of the accident, the hour, the day, and the month. So notably, what we want to know is the month in which the accident took place. So right now, what you might be thinking is, okay, we can use, we can simply grab this table, for example, and then we can aggregate by month, and then we'll have the total number of accidents per month. But there's a slight, error there, which is basically here you have data for all the accidents in France. So in our features table, we have even accidents for people that are not insured by us. And for our analysis, we only care about our clients. So we want to basically somehow verify that the clients that we have, that the rows that we have here are, well, from our clients. So how do we do this? How do we mix these two columns? What we're going to use is a join statement. So we're going to see how a join statement works. So I'm going to switch to the presentation, to the slides again. So here, let me just show you. Here, I want to show you how joins are going to help us solve this question. So the idea is that we have two tables and we want to use them together to solve a question. So how does a join do this? Well, there's several types of joins, and I'm going to explain how they work. So when you have two tables, for example, here, consider table 1 and table 2, you're going to be able to join them, for example, using their product column. So I could go, for example, and if I want to know the price of kiwis, I go to table 1. If I want to know the quantity of kiwis, I go to table 2. If I want to know the 2, I can simply go and find kiwis from table 1, kiwis from table 2, and then I put these two values together to create a new column, a new table that has price and quantity. Okay? So that is how a join works. However, there's something important here, or there's some cases that we're going to need to handle, and that is when one of the let's say when there's not a match between the two columns we're trying to identify. For example, if I search for strawberries in table 2, you see that strawberries is not there. So what do we do? Should we create a table that has only the price for strawberries, but not the quantity? Should we ignore strawberries? That is what the inner join is going to tell us. For example, the inner join, so it's a particular type of join where we only keep the rows that have a match. So for example, here kiwi has a match, bananas has a match, tomatoes has a match. So these three are going to be kept, but then strawberries and broccoli do not have a match in their opposite table, so they will be lost. Okay, so the inner join only keeps the rows that have a match. So you see here, kiwis has the price from kiwis, table 1, and the quantity from table 2. If I now choose a left join, I'm going to basically call the first table that I mentioned the left table, and then the second one the right table. And what I'm going to do is I'm going to keep all the products from the left table. And if I don't have a match, for example, for one product, I'm going to leave an empty value. So just to make sure this is clear, what would be the products that I'm going to get in my table after I do a left join? I see here some comments that basically are telling me that I need to use a join, and that's what we're going to do in just a second. So I see some people are using an inner join, others maybe want to use a left join. It depends on the context, that is true. But we will see in just a moment which is the one we will use. Okay, here we see that kiwis, bananas, and tomatoes are on the left table. So those are the ones that are going to be kept. Oops. There's one slide missing. Okay. So basically what we would get is this table with all the quantities, but a null value for the strawberry. But fortunately, I have, oh, there it is, sorry. So here's the left join. So when we get all the values, so kiwis, bananas, tomatoes, all the left products, all the price values because they were originally there, and then all the quantities except for strawberries, which has, well, there's no value for strawberries in table 2, so we just leave a null value. We can do the same thing with a right join. So a right join as you might expect, is going to keep all the columns, all the values from the right column. So here we keep kiwis, bananas, tomatoes, and broccoli, but there's no price for broccoli because it's not on table 1. So we leave a null value there. And finally, there's the full outer join where we're going to keep every row. And if we don't find a match, we just add a null value. So strawberries doesn't have quantity and broccoli doesn't have price. So those are the SQL joins. Now, what we need to do is, okay, which one are we going to use for our case? So in this case, we want to know the month and we want to make sure that it's a value that is in the customer base table. So how do we ensure that? Well, here we're going to use a inner join actually, because the inner join is going to make sure that the result that we get is in table is one of our customers, but also it has the month as well, because if we don't have the month, we're not going to be able to well use this information. So we're only going to keep the rows that we can use. There, of course, there's a subtlety. So we're losing we might lose some rows of some of our clients, but this is something that, depending on your use case, well, if you see that they're statistically irrelevant, you can simply approximate and keep only the statistic based on the rows that have a match. So we're going to perform an inner join. And how do we do this? The idea is that we're going to select everything from features, and then we're going to say inner join, and then we specify the second table, customer base. And then what we're going to say is we want to match. So how do we match these two tables? We're going to say on. So on which columns? We're going to say, okay, match them where features dot number accident. So where the identifier, the column that is in both tables, is equal. So where features is equal, features dot number accident is equal to customer base. Oops. Customer base dot number accident. So here we're saying where this column, so this is basically, you can think of this when you use this dot like using the first and last name of a column, right? So the first name is the table, and then the last name is the column. So this uniquely identifies the column on the features table, and this uniquely identifies the column on the customer base table. So when I do this, I get a new table, and take a look at this. This table has the information on the accident. So you see the year, month, day. But then it also has the information on the premium subscription, the cost, the license year, the vehicle age, the gender, the client age, and so on. Okay, so here, well, now we have the information that we want. We're going to go and grab the cost, sorry, the month and the cost. These are the two variables that interest me. And then I'm going to group by, again, So remember, we can get the average per month by using a group by. So I'm going to add a new row, which is called group by. And then I'm going to say group by month, for example. And then what I'm going to do is, again, average over the cost. And when I do this, you see that I get the cost for every month. I'm going to remove this so I can see all of the months. You see here I have the months from 1 to 12. Again, this is not very easy to read, so I'm going to order this by month, order by month. And then you see I have the months from January to December and the average cost. So here we see that it's not that interesting actually. Basically, all the months have an average, the same average cost. So it seems like the month doesn't influence the cost itself. But what about the number of accidents? So what we can do is we can also add a new column. So I'm going to add here a comma, and then I can use a new function that is called count cost. So what this is going to do is it's going to count all the lines for the same month. So when I do this, I see that now there is a difference. For example, you can see that November has almost 1,000 accidents, but then on April, there's almost half. On February, there's almost half. So even if the cost of the accidents is on average the same, we have months that are more costly to us in terms of the quantity of accidents that happen in that month. Okay, so basically that was what I wanted to show you. There's maybe one last part I can show you. So uh, so far we have used this in Snowflake, but the idea is that with SQL, you're going to be able to go grab the information from your data warehouse and uh, and then insert it into a basically wherever you want to use it. So here I'm going to give you a short example on how to insert it into Power BI. So just give me one moment. So here, if you go to, for example, this is Power BI. So the idea is that this is not going to be a tutorial on Power BI, but it's to show you how, in the end, you can connect this to other tools. So if you go to Get Data, you can go and search for Snowflake, for example, and you can connect to Snowflake. Here, you're going to need to connect to your data warehouse. For example, here, let me just really quickly. I need to basically add all the details that are needed for the to connect to the data warehouse. And then I can add an SQL statement here. And when I click on this, you see that I get the results I previously showed you. So I can load, for example, this data to Power BI. And then, okay, it's taking a bit to load. And then I can use it to create a visual. For example, here, I'm going to um, create a visual that displays the mean cost and the number of accidents as a function of the month. So here you see that the mean cost is roughly constant, while the number of accidents does have peaks and a clear seasonality that well, it's definitely going to impact into the operations of the insurance company. So I hope that helps you get started with SQL. Of course, there's a lot that is missing to learn. This was just to show you some basic queries and how all these queries, let's say, help you exploit the data that you have in your companies or in your um, wherever you plan to exploit them. So SQL, just to conclude, is one of the languages that is most well, the most prevalent when when handling with databases. So it's almost impossible not to see SQL in data. Now, if you have any questions, this is the moment. So I see there's only one question. This is more of a more advanced question. Yes, I would say it's better using a stored procedure, but let's say it depends on the particular case you're dealing with. Let me see if there were on any other questions up here. Is it better to fetch data from a table than running a request each time? So I'm not sure I understand this question. It so it depends. So if you want to have, for example, a live feed to a to a Power BI dashboard or something like this, you're going to need to do the request every time. If it's a static dashboard, for example, or a static visual that you want to create, you can simply basically bring all the tables if it's not too heavy, and then you're not going to. Okay, so thank you. Thank you for your input. Okay, folks, thank you for your time. So if, let's say, I invite you to contact us if you're interested in, let's say, signing to one of our programs. Uh, you can contact us, and we are happy to give you more information on whatever you're interested in pursuing in your data careers. Thank you, folks, for your time again, and yeah, happy coding in SQL.